Let's start. A binary, this is coming from Wassce 2016, question 1. And the same question like this is also at Wassce June 2012, question 1. Same question 1 like that. Alright, so let's start. A binary operation star is defined on the set of real numbers by P star Q. P star Q equal to P squared minus 2P Q. A. Determine whether or not the operation star is commutative. In fact, from the year, when you refer to the year, the question, there is nothing like associative. It's only commutative. That A plus the B. That is to find the true set of P star 4 equal to 9. I intentionally added the associative because after this, I won't be solving any relating question to this with you again. So I'm adding the associative in case you meet certain question like this, and it's not going to be commutative, but rather what associative. So I'm adding the associative as a bonus to you. So let's start. Okay. So from the question, there is a relation given in the question. Write that first. P star Q is equal to P squared minus 2P Q. Alright. A. Determine whether or not the operation star is commutative. So for a relation to be commutative, then P star Q will be equal to Q star P. Okay, so now from the question, we know that P star Q is, from the question, we know P star Q to be P squared minus 2PQ. So we are going to name this as our equation 1. Then we move on to Q star P. So we are still using the relation in the question. So where you see P here, replace that by Q. Where you see Q here, replace that by P. So this is going to give you Q squared minus 2QP. Alright, and you can simplify this. We can simplify this to Q squared minus 2QP or QPQ. 2PQ. And we are going to name this as equation 2. Very good. Now, after doing the substitution, is it true that P star Q is equal to Q star P? Is it true? Check equation 1. P squared minus 2PQ. Q squared minus 2PQ. Are they the same? No. Say minus 2PQ, say minus 2PQ. But this is Q squared and this is P squared. So you cannot conclude that since equation 1 is not the same as equation 2, then the operation, please continue, then the operation star is not commutative. Then the operation star is not commutative. So that is how we check for commutativity of a binary operation. Alright. Now, let's go to the II part. That is the associative. That is the associative. So let's check on that. Let me do that here. II. Now, whenever you are dealing with the associative deal with combining three things: the commutative and is it distributive? Oh, sorry, it's distributive rather that combine three things, but associative combine only two things. Okay, only two numbers. Let me say numbers. All right. Yeah. So let's go for the associative. The associativity is about three numbers. So let's pick P, Q, R. We are using P, Q, R. So for each to be associated, then P star Q will be the same as this. And this is supposed to be equal to P star Q star R. Watch. There is nothing like already here. Just pick three numbers. I know from the person it's only P and Q in the relation, but you add arrow to it. So you group it like this. First, you leave the last number. Then, if you want the other part, you leave the first number. Oh, you can even bring this one here and bring that one here. It's still the same thing. Nothing changed. It's still the same thing. Alright. So just know how to write this in that. So now, from the question, we know P star Q. Okay, so we are going to take the left hand side and solve. After that, you pick the right hand side. Solve. When you are done, you come and what? Compare. After that, you come and compare. So this P star Q, which is equal to this. Okay. So now let's go. So I'm continuing from where I reached. From the left hand side, what is P star Q star R? We know P star Q to be this. That is P squared. Please watch, it's not difficult. P squared minus 2PQ. R star R. That's what it means. Because we are picking the left hand side. And P star Q is this. So now let's continue. So now that we have this, combined with R, we are still using the relation in the question. So everything here is going to represent the P. Take note. Everything here is going to represent the P. And everything here is going to represent, the R here is going to represent the Q. So let's continue. So PQ, and we know that P squared minus 2PQ star R is equal to. So PQ is the same as the whole of this all square, because the first square, I hope it's clear. We are not done. Minus 2PQ. That's what it means. That's what it means. Hey, think there's a mistake somewhere. So the P square means the whole of this square. And the next one will be what? Minus 2P. So minus 2. P is this. So the whole of this will come again. So 2PQ. And Q is representing the R. You see that? The Q is representing the R. So multiply by the R. Okay. And this one, you can simplify it and leave it. So p square minus 2pq minus 2r whole square. 2r 2r multiplying p square minus 2pq. Okay, so we can name this as our equation 1. After naming this as our equation 1, this is representing the left hand side. Now from the right hand side, which is this. So from the right hand side, P star Q star R is equal to still referring to the question or the relation in the question. P first, P is here. So when you see Q here, replace it by the whole of this. But let's go and do bond mass first. Let's first go and find Q star R. So Q star R will represent the Q represents the P here. If you don't understand anything, pause the video, go back and play it again. You get it. The Q represents the P here. The R represents the Q here. So wherever you see P here, put Q there. Wherever you see Q here, put R there. So this one, we are only doing this. So this one will give you Q square minus 2pq. So here will be 2qr. Clear? Where you see P, put Q there. Where you see Q, put R there. Now, we now come and combine the P by Q square minus 2qr. You see that? We are left with only this to go. So now this one too will be equal to. So here we are still referring to the relation in the question. That is your guide. P represents P, but Q represents the whole of this. So P squared, no problem, because P is here, minus 2P. 2P. Where is P? P is P here, so no problem. 2pq. Q is what? Q is the whole of this here. Because P star Q. P star Q. So when you see P here, put P there. But when you see Q here, put the whole of this there. So this is going to be P square. No. There is a Q. Okay. So Q square minus 2qr. That is the associativity. That's the associativity. And you can end it here and name it as equation 2. So now this is the equation 1. The equation 1 from the left hand side is this. The equation 2 from the left hand side. The equation 1 from the left hand side, the equation 2 from the right hand side. So now compare this and this and check if they are equal. If they are equal, then we can say that the operation star is associative. If they are not equal, then we say that the operation star is not associative. So watch. Well, you can see comparing this to this, you can see that they are not the same. So therefore, since conclude, right conclusion. Therefore, since equation 1 is not the same as equation 2, then the operation star is not associative. It's not associative. It's not associative. Alright. Very good. That's all. That's all for that. Let's look at the B. The last one. The B. This preamble is what we are using to solve everything here. So we are still using this in the question to solve for B. The B says that you have to find a true set of P star 4 equal to 9. So where is it you put P there? Where is it you put 4 there? So P squared minus 2PQ, Q is 4, equal to 9. So you are finding the true set. And you can see that a quadratic equation will form. P squared minus 248. So 8P minus 9 equal to 0. So when you solve this, what are you going to get? You write it for that is 9. Okay. So when you solve this quadratic equation, okay. So when you point this on your calculator, you're going to get negative 1 and 9. You're going to get negative 1 and 9. So you're going to get P is equal to negative 1, P is equal to what? 9. But it's a scientific question, so you have to show working. So you write it in a factorized form, which is simple. P plus 1, but you said this one here, so P plus 1. Then P minus what? 9. So therefore, you conclude that when P is equal to 1 or P is equal to 9 is the solution to the equation. Thank you. See you in our next video. All right. Bye bye.